Hi everyone, welcome back to the second lesson on gradient. So this time we have not been given diagrams, we've been given coordinate points, which means we need to draw our own diagram, don't we? So for this first one, now excuse my hand-drawn diagram, you of course would use a ruler and do this neatly. For my first one I have the point 3, 4. So that means the x value of 3 and the y value of 4, and there's a point here which is labelled point A. Then we have point B, which is at 5, lines up with 5 on the x-axis and 6 on the y-axis, and so if I join those two together I'll have point B. Now that's starting to look a little bit like what we had in our last lesson. So let's use my red pen this time to mark in the rise and the run. So the rise, the vertical arrow here, is going to be the difference between the 6 and the 4, the y coordinates of the 2 points. And the run is the horizontal arrow, which will be the difference between the 3 and the 5. Now, I'll get my formula going here. Gradient, m for gradient, rise over run. Now I'm just going to highlight these numbers because that is going to be the vertical distance of that arrow. It's changed into a green arrow now, hasn't it? So in my working I would show 6 take 4. They are the y coordinates. I'll highlight the y coordinates of the points. That's where they came from. For the run, I'll use a different colour highlight for the run. For the run, for this distance, it's going to be the change there between the 3 and the 5. And the 3 and the 5 were the x coordinates of the points, weren't they? So in my working, I would take the 5, take the 3, and that becomes 2 over 2, which is a positive 1 gradient. Now that makes sense because there is no line joining the points, but I could put a line between the points. Let's have a nice blue line. Hope I can draw this neatly. That blue line joining the points would have a gradient of 1. We can even talk about the gradient between the points even if there's no line there. Now, the next one will be done in a similar way. I'll just slide across there to the side a bit. I'll draw myself a new diagram for each one because it might be a bit confusing. I notice in this one I'm going to have points on the negative side and on the positive side of the scale. Give myself a bit more room. Point A is at negative 3 on the x and positive 6 on the y. So that's point A up there. Point B is at positive 1 on the x-axis and negative 3 on the y-axis. So that's point B. Now the red pen for the rise and the run. Again, starting over here with point A, I'd have to move forwards and then I'd have to move downwards. That's the rise and the run. Once again, it'll be a case of looking at the numbers on the x and the y axis, won't it? So I've got a negative 3 and I've got a positive 1 as the x coordinates. Negative 3, positive 1. Now this one's a little bit more tricky because we have to imagine we've moved 3 steps forwards, then 1 more. So that's actually a forwards distance of 4. The y coordinates this time are going to go from positive 6 down to negative 3. There it is, positive 6, negative 3. Now that's a difference of 9. So we've gone from 6 all the way down to 0, then we've gone 3 more below 0, and it's definitely a downwards movement. Now let's do our working. Now that we have a picture, we'll do our working. M equals the rise over the run. Now, just like last time, The vertical, the rise, is the y coordinates. And I'll do the second one here, -3, subtract the first one, 6. The run is the green ones, the x coordinates. I'll do the second one, 1, subtract the first one, -3. So -3 take 6 is -9. 1 subtract negative is the same as add. That's 4, which means I have the number -2.25. If we had a straight line between point A and B, that would be a negative or a downwards gradient. There it is, a downwards gradient of -2.25. Thanks for watching.